Hi everyone, I would like to welcome you to my YouTube channel. So in this channel we'll break down the concepts of grade 12 subjects like geography, physical sciences, maths lit, and life sciences. And I'm really happy, I must say, to begin this series with you guys, and I hope that we will grow together as a channel and that I will be of great assistance to you guys. Thank you for tuning in, and I hope you will be part of this incredible journey with us. Okay, so in this video we will go through the geography paper 1 that was written in this month of November 2023, and we will look at all the questions. I'll start with the climatology and weather, which is of course in question 1 in section A, and we'll carry on doing and breaking down other topics in other sections as well. Okay, so now the aim of this video, guys, is basically to put into effect or basically implement what we have been learning in our TikTok series. Okay, so if you do not know about this, please check out my TikTok page. There, of course, it's at Science Guy RSA 99. Okay, so I'm gonna write it down here for you, and I'm also going to leave it, of course, in the description. Science Guy RSA 99. Okay, right. Okay, so let's of course begin with the first question. Okay, so I'll really be happy if you guys really do interact, comment on what you guys did, right? Because I do not have access to the memo, of course. So I'm just basically implementing, applying the knowledge that we have been that I have been like posting online in TikTok. Okay, so we'll begin with the first question, climate and weather. Okay, so in the first page we have a synoptic weather map. Okay, and it's quite important that you really interpret the synoptic weather map before you answer the questions. Okay, because of course all of those symbols really tell you a story. They really tell you a very very important insights. Of course the questions are based on this. So we'll begin with the first question, which is question 1.1.1. Okay, so we have a table, column A and column B, and we are supposed to complete the statements in column A with the options in column B. Okay, so we will write, of course, either one of the alphabets Y or Z next to the question number. Okay, it's very important that we follow instructions, guys, or else that will be the end of us. Okay, so question 1.1.1 says the synoptic weather map illustrates typical dash conditions. Okay, so in column B we have two options. It's Y, meaning which it illustrates winter conditions. Z, an option suggesting that it rather illustrates summer conditions. Okay, so let's go back. Let's go back to our diagram, our synoptic weather map. So what do we see? What is that do we see? So first of all, we do see a thermal low, okay, in the interior of the country. Okay, so so let me just have an illustration right over here. So why would you have a low pressure in the interior of the country? Okay, first of all, how is an area of low pressure created? Okay, so an area of low pressure is created, first of all, you have to have sunlight. Okay, so or sun's rays whatsoever. Okay, so what happens is that when you have the sun, it transfers heat to the surface. Okay, so the surface gets heated up. Okay, so the surface gets heated up, and it transfers this heat to the surrounding air. Okay, so it transfers it to this air through a process that we call conduction. Okay, this is a type of heat transfer that we call conduction, and it usually requires contact. Okay, sort of like when you are basically cooking. Okay, so your stove is in contact with your pot. Okay, and so the stove gets heated up and then basically heats the pot up as well, and so that heat is transferred through conduction. So this is what is happening here as well. You have the surface gets heated up and it transfers this heat to the air. So now the air, what the air does is that changes this heat, converts this heat into kinetic energy. Okay, so for those who don't know kinetic energy, this is simply the movement energy. Okay, so that is movement energy. So it basically provides it with energy to move. So now you have warm air. Okay, because of course it has been heated up and it has this kinetic energy. What does it do? Okay, it rises up, guys. It rises up. Okay, that is basically what happens. Okay, so how does this relate to pressure? Okay, now pressure basically of course is like basically the amount of force that is applied per unit area. Okay, so if you of course apply a huge amount of force, let's say you have maybe a car. Okay, if I would ask you, if you have a car and maybe a bunch of leaves, okay, that occupy the same area. Okay, let's say these are many leaves, they occupy the same area, the car occupies the same area as well. Which one applies a greater force? Yes, of course you would say it's the car. Okay, it's the car. Why? Because it applies a greater force. That's why, hence a greater pressure. Okay, so the car applies a greater pressure because it applies a greater force. Okay, and it's always relative to the ground or the surface. Okay, so you have warm air rising up. How much force is it applying on the surface? Okay, it's rising up, right? So how much force is it applying on the surface? How much pressure is it going to apply on the surface? There's very little pressure. Okay, that's why we say an area of low pressure is created, because they do not press against the ground like when you have cold air. Okay, cold air presses against the ground, and hence cold air is always associated with an area of high pressure. Okay, because it exerts a force towards the surface, and so there's an area of high pressure created on the surface. Okay, so what does this mean for our answer? Well, because we do have a low pressure here, what does this mean? This means that air is actually rising up. Okay, and so when would you have air rising up? When it is hot, when it is warm. Okay, so when the temperatures are high. So, and that also brings me to another clue that you have there. You can also look at the weather stations as well. Of course, you see that the maximum temperatures, you have your 30 degrees Celsius, 28 degrees Celsius, 26 degrees Celsius. That means that it is warm. It is summer, guys. Okay, can't be winter. Temperatures have to be generally low. Okay. What else can you see? Well, you can also see that the mid-latitude cyclone is further south. Okay, so it is further south. So of course that means that it is not winter. Remember, mid-latitude cyclones only affect South Africa, the southern region during winter. Okay, so because it's not there, that means it is summer. Okay, so that is summer. Okay. So we're saying that it is summer, and summer of course corresponds with the option Z. Okay, so it's the second option, summer. Okay, let's head on to 1.1.2. 1.1.2 states that line A-A represents a. We have two options, a ridge representing a ridge, that's Y, and the Z option is a trough. Okay, so what are these two concepts, guys? What is a ridge? What is a trough in climatology? So a ridge, okay, is an elongated, okay, so it's an elongated area, okay, of relatively high pressures, okay, of relatively high pressure, okay. And then a trough is an elongated area as well, of relatively low pressures, of course. Okay, low pressures. Okay, so these are like in topography where you have um, a ridge. You know that basically a ridge, it's basically like a mountain that continues on with a lot of mountains. Okay, like that. So that is the whole ridge. Okay, so a ridge, we can say that it is a high-lying area like that, or a mountain. Okay, and then a trough is a low-lying area like a valley. Okay, so in terms of we're looking at it in terms of the pressures. Okay, so this has relatively higher pressures, and this area has relatively low pressures. Okay, so that's a ridge, and that is a trough. Okay, so looking at this line, what's happening here? Okay, so what do we see? Okay, so we see, okay, this is a low pressure. Okay, and of course from the area of the low pressure, it then increases. Okay, the pressure increases going on to the high pressure. So that's a high pressure, low pressure, high pressure. Okay, so in this area you have so looking at the isobaric interval. Okay, isobaric interval, guys, is the interval or the difference between consecutive isobars. Okay, isobar interval, also the isobaric interval. So basically just look at isobar. So this is 1020. What's that? Okay, because that is a 1012. Okay, so if this is a 1012 and this is a 1020, what's that in the middle? And also we can also get clues from here at the bottom. That's 1000 hectopascals. It's followed by 1004. So this means that the isobaric interval is actually 4 hectopascals. Okay, so if this is 1020, we go down, okay, by 4, and so that is 1016. That's 1012. This is 1008. Okay, so as you can see, if you're moving from this area going towards that side, okay, you are increasing. Okay, you are going up in so you're basically going up in pressure. Okay, and so moving from this region towards that, you are going low in pressure, and then going high again. Okay, so going high again. Okay, going that direction. Okay, so what is this region then? What is this area? Okay, because you are increasing in pressure, and these are relatively higher pressures. Okay, so this would have to be a ridge. Okay, this has to be a ridge, guys. So that is how you look at these two concepts. So it is a ridge. So line AA represents a ridge. A ridge corresponds with the option Y. Okay, so it corresponds with Y. Right, so let's move on. The air pressure reading of isobar B is dash hectopascals. Okay, of isobar B is dash hectopascals. Okay, so again we go again and look at isobar B. So looking at isobar B, as you can see, so the isobaric interval in this case would help you a lot. Okay, very important, guys, know this. So let's look. Let me demonstrate this again. So you have 1,000 hectopascals. The next isobar going the next isobar, the consecutive isobar, is 1,004. Okay, so this means that this isobar, the following one, has to be 1,008, right? Has to be 1,008. Okay, and then the following one, meaning which the B isobar, of course, has to be 1,012, guys. Okay, so it's basically just adding fours there until you get to B. Okay, so it has to be 1,012 hectopascals. Let's look at what options do we have there. Yes, there we go, 1,012. So our answer has to be Y. So it's basically just knowing the concept of isobaric interval, because they are not going to write all the isobar values for each and every isobar. Okay, you have to know the isobaric interval. Okay, so let's move on. The next question says the air pressure gradient is steeper around the weather station at D or at E. So we have two options. We have D and we have E. Okay, so this is D and that is E. Okay, so what is a pressure gradient, guys? What is a steep pressure gradient? How do we see a steep pressure gradient? How do we see a gentle? Because there's a steep and a gentle pressure gradient. So if you were watching my TikTok videos, you should have of course gotten this. So a steep pressure gradient, it is on an isobaric, on a synoptic weather map. You see it by isobars being close. Okay, so if your isobars are close, then we say that this is a steep pressure gradient. Okay, this area, in this area, you have a rapidly rising air. Okay, so if the air is rapidly rising, what type of clouds are you likely to form? Okay, so it's fast, like it's rising very fast, and so it's able to build. Okay, when it condenses, it's able to build those tall clouds, which we call cumulonimbus clouds. Okay, so steep pressure gradient is always associated with cumulonimbus clouds because of that fast rising of air. And number two, the wind speed is generally higher in steep pressure gradient. Okay, wind speed is high. Okay, and then it's the opposite here. Usually have form thinner clouds like your stratus, your cumulus, so on and so on. Okay, because the air is rising slowly. Okay. Okay, so, and you can also see this by the shapes that you see when you are drawing the mid-latitude cyclone. Okay, the fronts. Okay, the cold front is associated with, this is steep, as you can see, so it's associated with a steep pressure gradient, and this is associated with a gentle pressure gradient. Okay, that's why you have cumulonimbus clouds here. That's why you have, of course, your nimbus stratus clouds. So 1.1.4 has to be B. Okay, has to be B, guys. It has to be D. My mistake. It has to be D, so it has to be Y. Okay, so it is Y. Okay, let's move on to the following question. The northeasterly wind at Durban is influenced by the dash circulation of air. Okay, so we're saying that the northeasterly wind at Durban. Okay, so of course, if you look back again to looking at our synoptic weather map, as you can see, we have a weather station that has north easterly wind direction. Okay, so the wind, meaning which the wind or the air is coming from the northeast. Okay, what do you remember? What concept do you remember about having winds coming in from the northeast? Okay, that is your line thunderstorms, guys. Okay, so the reason why it's coming from the northeast, well, that's because you have, illustrating you here, you have the anticyclone, the South Indian, okay, anticyclone, okay, and this, of course, each and every anticyclone has an anti-clockwise circulation. Okay, so of course wind is going to circulate anti-clockwise, in an anti-clockwise direction. Okay, so that means that you are going to have winds that are approaching the shore from the northeast, okay, because of this anti-clockwise circulation. Okay, so of course our answer there has to be anti-clockwise. Okay, so it's influenced by the anti-clockwise circulation of the anticyclone or South Indian high pressure. Okay, so that is y again. So that is y. Okay, so that is y. 1.1.5, that's y, our answer there. 1.1.6, the unstable weather conditions at weather station C. Okay, let's look at weather station C. Okay, so there it is. Okay, so what about it? So the unstable weather conditions at weather station C are due to, okay, the development of a dash front. Okay, so we do see unstable weather conditions. So unstable weather means wet weather, violent weather, aggressive weather, full cloud cover, rain, fast winds, so on and so on. So that is unstable. Okay, when you have rising, basically when you have rising warm air, which of course results in condensation, then formation of clouds, then rain. Okay, so why do we have that at sea? Okay, remember C is at the interior. Okay, so illustrating here, there we go, there we have C. It's at the interior of the country, and as you can see here, we talked about the northeasterly winds. Okay, so they approach coming in from the northeast. Okay, and then of course you have the cold dry winds coming in from the south west. Okay, and they meet up along what we don't see here. What's that? Okay, so that's the name of the front. So the name of that front is called the moisture front. Okay, again guys, line thunderstorms. Okay, this is a concept from line thunderstorms. Okay, if you don't understand line thunderstorms, then it will be difficult for you to get this one. So this is of course due to the development of the moisture front. Okay, so these winds, the warm moist winds and the dry cold winds. Okay, dry and moist. So of course it's a moisture front. Okay, boundary between different winds or air in terms of moisture. So it's due to the moisture front. So our answer is Z. Okay, our answer is Z. That's 1.1.6. Let's head on. Which 1.1.7? Which weather station illustrates the following weather changes at F in the next 24 hours? Okay, what's going to happen in the next 24 hours? Okay, well, okay, and then we have more information. The wind direction changes to southwest. The air temperature decreases by 6 degrees Celsius. Now, this is, of course, you apply your knowledge of weather stations here. Okay, so which weather station illustrates this? Which weather station illustrates southwest wind direction? Okay, well, both of them. Okay, so both of them do illustrate southwest wind direction, so we cannot choose based on that. Let's look at the second one. The air temperature decreases by 6 degrees Celsius. Okay, let's look at F. F has an air temperature of 30 degrees Celsius. Okay, and which one illustrates a decrease of 6 degrees Celsius? Okay, is it Y? Is it Z? Yes, it is Y. It is Z, I mean. So it is Z because it's 24 degrees Celsius. F was, of course, 30, so that's a decrease of 6 degrees Celsius. Okay, so that's how you choose. So it has to be Z. Okay, so that is your question one. And so we move, guys. We move on. We move on. So let's head on to 1.2. Okay. I hope you guys are did score those, get those marks. So for 1.2, okay, various options are provided as possible answers to the following questions. Choose the answer and write only the letter, okay, next to the question number from 1.2.1 to 1.2.8. Okay. So what do we have here? We have a sketch. Okay, we have a diagram here. So and it's based on the questions that are going to be based on this diagram is from 1.2.1 to 1.2.4. Okay, so what concept do you see here? Okay, that is of course your valley climate, or micro. It's part of the microclimate. So it's the first concept. Okay, so which is basically aspect. Okay, so we talk about aspect there, which is a relationship basically, or rather looking at which angle, or what angle do the sun's rays strike the surface. Okay, that is your slope aspect. Okay, so let's look at 1.2.1. It says the relationship between slopes and the sun's rays is referred to as, what did I just say? So of course it is slope aspect, guys. Cannot be insolation. Insolation is incoming solar radiation. Yes, it's aspect. Okay, cannot be north facing slope. It cannot be terrestrial radiation. That's the cooling off of Earth. So it has to be B. So 1.2.1, that's B. The surface from A to B is intensely heated because, okay, so of course, as you can see from the diagram, A and B receives direct sun rays, guys. Okay, they do not receive oblique. They receive direct sun rays. Okay, so it has to be. It receives direct sun rays, so that has to be C. Okay, can't be is because at lower latitude, no. At higher altitude, no. It's direct sun rays. Okay. And then the climatological phenomenon occurring at sea is, okay, so what's happening at sea? So of course, as you can see at sea, we have a valley there. Okay. So what happens in a valley, guys? Which climatological phenomenon do you usually get on the valley? Okay, it is the frost pocket. Okay, so it's the frost pocket. So that's D. Okay. All right. Right. So and then your 1.2.4, dense vegetation is found in the shadow zone due to dash conditions. So what conditions do you have on the shadow zone? Do you have warm conditions? No. Okay, it's the shadow zone because the sun's rays do not strike the surface there. Okay, so it's basically in the shadow. So it's not warm, it's cool actually. B, dry. No, it's not dry, it's actually moist. Okay, so C, yes, that's a good one. And D, windy. Okay, we don't know about windy. but we definitely are confident about moist and cool. Okay, so we are going with C for 1.2.4. And then and by the way, guys, just